Hey guys, welcome back. I'm Darshan from SVC, Department of Computer Science and Cybersecurity. Today we discuss about the topic is Markov chains in mathematics. Introduction to Markov chains. A Markov chain is a mathematical model that represents a sequence of events where the probability of transitioning from one state to another depends only on the current state. Markov chains are widely used in various fields like including finance, physics and computer science and biology. The concept of Markov chains was introduced by Russian mathematician Andrei Markov in early 20th century. Key terminologies of Markov chains. State. Each possible situation or condition in a Markov chain is called state. Transition probability. The probability of moving from one state to another is known as the transition probability. Transition matrix: a square matrix that represents the probabilities of transitioning between states in a Markov chain. Markov property: the Markov property states that the probability of transitioning to a future state only depends on the current state and not on the history of events. This property makes Markov chains memoryless as they do not consider how the current state was reached. The Markov property allows for efficient computation and analysis of Markov chains. Homogeneous and non-homogeneous Markov chains. Homogeneous Markov chains have transition probabilities that remains constant over time. Non-homogeneous Markov chains have transition probabilities that can change over time. The homogeneity or non-homogeneity of Markov chain is determined by the properties of underlying systems being modeled. Observing and non-observing states. In Markov chains, observing states are states from which there is no chance of living. Non-observing states are states that can transition to other states. Observing states are often used to represent final outcomes or terminal states in Markov chain. Stationary distribution. The stationary distribution of a Markov chain is a probability distribution that remains unchanged, transitioning between states. It represents the long-term behavior of the Markov chain as the number of transitions approaches infinity. The stationary distribution can be calculated by solving a system of linear equations or by using eigenvector techniques. Applications of Markov chain. Markov chains have applications in predicting stock market movements and financial modeling. They are used in natural language processing for language generation and text prediction. Markov chains are also used in genetics and evolutionary biology to study DNA sequences and mutation patterns. A Markov chain is a mathematical model for stochastic systems where states, discrete or continuous, are governed by transition probability. Suppose the random variable x naught x1 and x power n take state space that is countable set of a value. A Markov chain is a process that corresponds to the network. Limitations of Markov chain. Markov chains assume that the future is independent of the past given the present state, which may not always hold true in real-world scenarios. They can become computationally expensive for large state spaces or complex transition probabilities. Markov chains may not accurately capture rare or unpredictable events that can significantly impact the system being modeled. Extensions of Markov chains. Higher order Markov chains consider the dependence of future states on multiple past states rather than just the current state. Hidden Markov models incorporate the concept of hidden or unobservable states, which can provide more flexibility in modeling real-world systems. Continuous time Markov chains allow for modeling of events that occur continuously over time rather than discrete time steps. Conclusion of Markov chains. Markov chains are powerful mathematical models that have a wide range of applications in various fields. They provide a framework for analyzing and predicting the behavior of the systems with probabilistic transitions. Understanding the concepts and properties of Markov chains can help in making informed decisions and solving complex problems. Jai Shri Ram.